All right, guys. Well, today we start our first lesson, and we're just going to start reviewing some things about equations and slope-intercept form, as well as with point-slope form, which some of you used, some of you didn't use last semester, but we're going to go ahead and show you the benefits of the two in order to write an equation. All right, well, here we go. If you see that we're going to start off with slope of a line given 2 points. So there's two formulas here, okay? I prefer to use the y1 minus y2 divided by x sub 1 minus x sub 2. You guys are probably more used to using this one. So at the end of the day, it's whatever you prefer and what works for you. The reason I prefer the y1 to the y2 is because it permits me to go from left to right, left to right, left to right, left to right. So, for example, looking at this first problem, to find the slope between 2 points, here's your x sub 1, y sub 1, x sub 2, y sub 2. So, just like when we read left to right. So why not plug in the slope formula from left to right? So left to right, we're going to start with the y's over the x's. Now, just a side note, as we know, slope is rise over run. It's also heard of as the change in y all over the change in x as another way to find slope. Now, some of you guys forget that the x's go on bottom and the y's go on top. Now, if you forget, just remember, the x's are the ones with 2 legs that are able to carry the y that has 1 leg. So x's are on the bottom because they have 2 legs to stand on. Think of it that way. All right, so here we go. For m, to find our slope, m equals, so from left to right, we put the y's on top, a -6 and a +10. A -6 and a +10. And remember, the formula is to find the difference of those two. Then we're going to put the x's on the bottom, so you have 4 minus a -2, 4 minus a -2. Now that we're here, and you guys can always pause if you need to, if you're writing this down as we go, or you can just try it and then see if you come up with the same answer. If not, you probably need to revisit the notes. Okay, so don't forget, back-to-back negatives as you're finding the difference in change. So 4 minus a -2 simplifies to back-to-back negatives. It's a plus. All right, so we end up with a -6 minus 10, which is a -16, divided by 4 plus 2, which is 6, so it leads us over here. Now you could simplify your slope, divide it by 2. 16 divided by 2, sorry, -16 divided by 2 is a -8, and 6 divided by 2 is 3. So your slope is a -8/3. So what I need to do is go and add a negative. Okay? All right, so I did that one. Let's go ahead and do this next one together. So find the slope of the line with 2 points. So the first thing I'm going to do, a little bit more workspace over here, is I'm going to go ahead and start off with my division bar. I'm going to put in the 2 minuses. And now, remember this is your x, y, and we're going to start with the change in our y's. So from left to right, 5 and 5. And then we're going to find the change in our x's, which is 2 and 6. So I put it in left to right as they appear. All right, so now 5 minus 5 is 0, and 2 minus 6 is a -4. Well, 0 divided by -4 is actually 0. So in this example, m is 0, which means these 2 points create a horizontal line since it has a 0 slope. But we'll talk about that a little bit more later. All right, the next one. Find the slope of the line with points 4, 3, and 4, 8. So because I did one and we walked it through, we did one together. Now I want you to pause at this time and you try the next example on your own. And then hit start when you want to see if you did it correctly. So I'm assuming you're done with the problem. So again, I'm going to start off with creating my fraction bar, putting the 2 lines in, and now I can go ahead and take the y's. So it's going to be 3 and 8. And then I'm going to take my x's, 4 and 4. Now 3 minus 8 is a negative 5. And that's all over 4 minus 4, which is 0. Okay, now when 0 is under the fraction bar, it is undefined. Just kidding. When 0 is under the fraction bar, undefined is what we say the slope is, which means this yields a vertical line. So whenever something has a slope that's no slope or undefined, we could say the slope is undefined. That's because it's a vertical line. Whereas a 0 slope is going to yield a horizontal line. All right. Now, I know I pre-filled this next one because I see it more as a challenge problem. So, with that, it says find the value of k so that the line through this point and this point has a slope of -2. So we know that the slope is -2, so what I'm doing is substituting into the slope formula. Here's my -2, and then this is going to, these two numbers represent the change in y, and these represent the change in x. Okay, so if you see here, I've listed it. Your x values and your y values, the change in y is a -8 minus k, and then your x values would be k minus a -11, hence k minus a -11. Okay, so it's pretty simple actually, because all we're going to do is start off by simplifying the denominator, which is going to give us k plus 11. Okay, so I'm going to take this work and make my way over here. So we've got k plus 11 is what we simplified. But notice that I turned the -2 into a fraction by putting a 1 under it. The reason I did this is because I wanted to use the cross product here. So I can multiply these two together, and I'll multiply these two together. So a negative, and so now I'm taking this work over here. All right, let me erase this since I already rewrote cross product. Okay, so now we're here. So -2 times this quantity will set me up for the distributive property. Okay, so, and then obviously over here, -8 minus k times 1 is just itself. Anything times 1 is itself. So now we're going to go ahead and distribute. So you get -2 times k, and then -2 times a positive 11, which yields -2 times k is a -2k, and a -2 times a positive 11 is a -22, which equals -8 minus k. The next thing we're going to go ahead and do is I'm going to go ahead and eliminate the variables. So I'm getting rid of the positive 2k, and what I do to one side I have to do to the other. So those cancel out. I bring down the -22, which is equal to the -8. Negative k plus 2k leaves me with a positive 1k. And so now all I'm going to do is move the constants to the left. So I'm going to use the inverse operation. The opposite of a negative 8 is a positive 8. So therefore, these will cancel out. And negative 22 plus 8 gives me negative 14, which gives me k. So k equals negative 14. So if I were to go back up, and now I know that k is, I know k is a negative 14. My ordered pairs would be negative 14, negative 8, and negative 11, comma, negative 14. If you guys were to check your work, you would find that the slope is negative 2. All right, so that was just a fun challenge problem. All right, so let's go ahead and take a look at all this other stuff. Okay, I pre-put some notes just because I'm trying to keep this video to no more than 30 minutes because of the upload time it takes on my end. So here we go. Horizontal lines have a slope of 0. So here's your horizontal line, slope is 0. This is kind of where my HOI comes in. It's an acronym to help me remember that horizontal lines have a 0 slope, and the type of equations is like a y equals a number equation. Okay, the next one, vertical lines have an undefined slope, or some say no slope, which is undefined, which is a vertical line. Hence, I like to use the acronym VUX for vertical, undefined, and x equals a number type of equation. All right. Now, we always read graphs, like I was saying, from left to right. We do a lot of things from left to right, so it makes sense to read our graphs from left to right. So lines that rise from left to right have a positive slope. So from the furthest left point to the furthest right, it's like you're going up a roller coaster ride, so your slope is increasing. It's positive. Lines that fall from left to right have a negative slope. So you look at the furthest left of the graph, which is this point, and from left to right, it is actually going down, so we would say the slope is decreasing. All right, now we're going to talk about lines that are parallel and their slopes. So in a plane, non-vertical lines with the same slope. So basically, let's just talk about parallel lines. Parallel lines have the same slope. Okay, parallel lines have the same slope. So whatever two equations they are, if they're parallel, you know the slopes are the same. So I'm going to go ahead and notice that I underlined that here, but I'm going to redo it here. Same slope. All right. Whereas if you have lines that run perpendicular to one another, in other words, for example, here they make a 90-degree angle at the intersection, their slopes are going to be opposite of one another, opposite reciprocals of each other. So to be clear, for example, if you have two lines that are creating a 90-degree angle when they intersect, that's because the slopes are opposite. One's positive, one's negative. And then reciprocals, the numerator and the denominator switch places. So here you have the 3 and the 4, but in the other one, it's the opposite, 4 and the 3. Okay, so if you have slopes of that nature, it's because the lines are perpendicular. So that's the only two situations you'll see. All right, intercepts. The x-intercept of a line is the point at which the graph intersects the x-axis. To find it, set y to 0. The y-intercept is the point at which the graph intersects the y-axis. To find it, you're just going to set x equal to 0. All right, so find the x and y intercepts of the graph of the line with the equation. All right, so to find the x intercept, based off my notes, I'm going to set y equal to 0. So I'm going to set y equal to 0 so that I can solve for x. All right, so in this equation, it's read 6 times x minus 8 times y equals 18. So since I'm trying to find the x-intercept, I'm going to let y equal 0. So 6 times x minus 8 times y equals 18. So again, to find the x-intercept, let y equal 0. So I'm going to go ahead and 6 times x stays there. A negative 8 times 0 is just 0 equals 18. And now to undo the 6 times x, the multiplication, we undo it by dividing out the coefficient of x. The coefficient is 6. Okay, but what I do to one side, I need to do to the other. Always got to be fair in math. So essentially what we get is 6 divided by 6 is 1x, which equals 18 divided by 6, 3. So when y is 0, x equals 3. And that's your x-intercept. Okay, so your x-intercept is at 3, 0. So notice that whenever you want an x-intercept, the y value is 0. All right, and then in this next example, we're going to find the y-intercept. And if you think about the y-axis, any point that falls on that y-axis, x is always 0. And then you go up or down, depending on what the y-intercept is. So we're going to, this time, let x equal 0 to solve for the y-intercept. So we're going to go 6 times x minus 8y equals 18. So again, we're going to let x equal 0 to solve for the y-intercept this time. So 6 times 0 is just 0, and you're left with a negative 8y, which equals 18. Now we're going to do divide out the negative 8 on both sides, and we get y equals. Now, here's the thing. We can just simplify this, but don't forget a positive divided by a negative is a negative. And we're just going to reduce this, simplify it, and divide by 2. So 18 divided by 2 is 9. And negative 8 divided by 2 is a negative 4. So in essence, 4 goes into 9 2 times, and then there's 1 left over. So we could put that as a mixed number, or for right now, we can just leave it as negative 9/4. All right, so let's go ahead and take a look at this next part. Okay, so slope-intercept equation. So we know slope-intercept is slope and the intercept. As a function, f of x notation, it's just y is the same as f of x. M is the slope and b is the y-intercept. We just got done talking about when you're looking for the y-intercept, x is always 0. So I'll go ahead and add that over here. Alrighty, so the y-intercept is where the line crosses the y-axis. Okay. Note, the powers of x and y are always 1. So y to the first, x to the first, with a linear function. All right, so if m equals 0, we have y equals 0x plus b, or f of x equals b. Again, we said another way to say f of x is y. And in this case, 1, 2, 3, y equals 3. You plot a point and put a line through it. So this is where that hoi comes in. So hoi, horizontal line, a 0 slope, and it's a y equals a number type of equation. In this case, y equals 3. All right, so that's this is a constant function, and the graph is a horizontal line. Now, let's look at the next one. Find the slope and the y-intercept. Okay, well, we know the slope is the coefficient of x, which is a negative 5. and the y-intercept is your b. Your b in this case is 3. So again, when you have a y-intercept, x is always 0, and the y-intercept is at 3. All right, so again, that's slope-intercept for you. Find the slope-intercept equation for the line with a slope of 2/5 and a point 0, -6. So find the slope-intercept form. So we need the slope, and this time they only give us a point. They don't give us b. So there's one of two ways that we can go about this, but we'll start with slope-intercept form, so we'll go ahead and plug this in. So y equals, the slope is 2/5, okay? We'll just do it like this for right now, okay? That's all we know because we haven't looked at the point. But here's the thing. What does this point represent? Well, remember when we said when x is 0, you have a y-intercept? So, because x equals 0, you know your b is -6. So yes, you have your m and you have your b. So I'm going to go ahead and erase that. And in this case, our b is a -6. And we know that because x is 0. All right, let's take a look at another one. Now we're talking about parallel and perpendicular lines. So the slope of all lines parallel to any equation, they're going to have the same slope. So in this example, the slope of all lines parallel to this equation is going to be a slope that is the same identified here. So if lines are parallel, it's because they have the same slope. If lines are perpendicular, then they're going to be opposites and reciprocals. So this happens to be the same one I talked about in the opening activity. So the slope here, in order for it to be perpendicular, the slope, so got to be opposites and reciprocals. So if one slope is a -3/4, it's going to be, the symbol for perpendicular is like this, without all the squigglies messed up, sorry. Okay, so the opposite of a negative is a positive, and the reciprocal of 3/4 is 4/3. So looking at the slopes alone, if they're opposite in sign and reciprocals of one another, that means that they're perpendicular, and when they intersect, they're going to create a 90-degree angle, which is really going to help you guys when you go to geometry in the fall to understand these things. All right, so you guys are doing great. Remember, if this is getting a little tiring, take a quick little break. Hit pause, come back to me. All right, so let's go ahead and take a look at this last home stretch here. Okay, we're now going to talk about standard form. In the previous examples, we talked about slope and slope-intercept form of a linear equation. Now we're going to look at the standard form of a linear equation where it's ax plus by equals c. All right, so write the standard equation for the given equation. All right, so what we're going to need to do is we need to go ahead and distribute here to get to standard form. So remember, we want the constants on the right. So y minus 4 equals, and now I'm going to distribute 2/3 x and 2/3 times a -4. Okay, so we're going to get 2 times -4 is a -8, and then 3 times 1 is 3. Okay, so we want to get the ax on the left side. So here is your ax, And this is your constant. We want that by itself. Okay. So I'm going to go ahead and move my ax to the left side by subtracting the entire term. So I'm going to go minus 2/3 x minus 2/3 x. So we bring down the y. We're going to bring down the y. The minus 2/3 x, the negative 4, which equals a negative 8 over, excuse me, 3. All right, now finally, since looking back up here, the ax and the by need to be on one side and the constants on the other. So we have our ax and our by on one side, and now we need to get the constant on the other. So now I'm just going to add 4 to both sides. And so I'm going to come up here and finish this off. And we're going to go y minus 2/3 x equals 4 minus 8/3. Now the one thing I should have had you do first is to clear the fraction. Okay. So that was my apologies. We should always clear the fractions and you should always have constants as your a and your b. So at this point, we're going to finish it off and get rid of those variables. So at this time, I can go ahead and clear the fractions by multiplying both sides by the denominator, 3. Okay, so when I distribute, I get 3y, and then when I distribute over here, the 3's will cancel out. So you're going to get negative 2x, and now here, technically I do need to distribute, okay, and then when I distribute here, the 3's cancel out, and you're left with a negative 8. So I apologize in advance, not clarifying that in the beginning. I should have done it. All right, so now 12 minus 8. So I'm going to go ahead and move the ax in front, and then the positive by, which equals c. So much easier if you would have cleared the fraction in the beginning. My apologies. Won't do it again. Maybe. All right, so that was a bit of a process. So in the beginning, let's go ahead and remember to clear that fraction. It'll save you some time and on the workload. All right, so next, and finally, this is the last home stretch of the notes. We've talked a little bit about slope-intercept form. We've talked a little bit about standard form. And now we're talking about point-slope equation of a linear function. So this, again, is very handy in geometry, and this is why we're taking it to that next level. So notice here, you're going to be needing to replace, let me go ahead and clear that. So you're going to need your y1, your slope, and your x1. So an ordered pair and slope to right and point slope. Hence, you need a point and you need slope. So for example, here, this first one's done for you. Notice that here's your y1, here's your slope, and here's your point. So that's where you would start with. But notice that an x minus a negative 3 simplifies to x plus 3. And now you're in point slope. And that's all there is to it. So looking at the last example, or not the last example, some examples. Give the point slope equation of the line with the slope negative 3/8 and a point 9, negative 10. All right, so the equation is y minus y sub 1, which equals m. M is a negative 3/8. X minus x sub 1, x sub 1, minus x sub 1. Whoops, sorry. Doop. All right, so let's go ahead and plug these in. So y sub 1, here is your y sub 1, which is negative 10. And your x sub 1 is a positive 9. Okay, so now all I have to do is simplify here. So y minus a negative 10 is actually y plus 10, which equals negative 3/8. And then in parentheses, x minus 9. So now we have an equation in point-slope form. And again, the reason that is because you're provided a point and you're provided slope. And so that would be the best way. All right, give the point-slope equation for the line with the point 9, negative 2 and is parallel to the line y equals 8x plus 1. All right, so again, give the point-slope equation for the line with point 9, negative 2 and is parallel to this given line. So the reason why they say parallel is because we need a slope. And we know that any lines that are parallel to one another have the same slope. So here, your slope is 8. So m equals 8. Any line that is parallel to this equation is also going to have a slope of 8. And we also have a point, so we're good to go. So what we're going to do is we're going to go y minus, open up your parentheses, equals your slope. Your slope is 8. And then open up your parentheses again, x minus your y1. And now we can drop in the values. So, your x1. So you're going to go ahead and plug in your y1, which is a negative 2. And then your x sub 1. Okay, your x1 is 9. So the x's go together, the y's go together, if that makes any sense. And then you just look to simplify. So y minus a negative 2 is actually y plus 2, which equals 8, times the quantity of x minus 9. I've got one more problem if you need me. Sorry about that. All right, so last example. If you guys want, you can give it a shot. Up to you. Hit pause. Take a deep breath, and then go at it. And then come back to me when you're ready to see if you got it correct. All right, so I'm going to assume that you paused and that you tried this. The key word here is perpendicular. Okay, when you have something perpendicular, it's because you know you have slopes that are opposite reciprocals. So here, if the slope is a positive 8, well, I need to get the other slope that's perpendicular. So the opposite of a positive is a negative, and the opposite of 8 over 1 is 1 over 8. All right, so now I have a slope and I have a point. Woohoo! So I'm going to go ahead and drop it in. Y minus whatever our y sub 1 is equals our slope, which happens to be a negative 1/8, times the quantity of x minus our x sub 1. So our y, so again, here's our x, here's our y. We need our y sub 1, which is a negative 2. And we need our x sub 1, which is a positive 9. So now when I simplify, y minus a negative 2 is y plus 2, which equals a negative 1/8 x minus 9. And now we have the point slope form of the equation that is perpendicular to this equation. Okay? All right, guys. That is the notes for today. I do have a practice, but I will go over the I will upload the practice and you guys will go ahead and complete that assignment based off of these notes. Because I did have a lot of other stuff that I needed you guys to do, like look at the introduction video, along with view the course outline, fill out the Google survey, look at the notes for today, and then do the corresponding assignment with the notes. I'm going to leave it at that today, so it'll be a short practice, but please take a picture of your work, scan it, upload it to Google Classroom, and submit. There is a how-to on the agenda if you need any help. And of course, if you get stuck, please reach out to me via email and we can figure something out.